All right, in this little screencast here, I want to teach you guys how to count. All right, that sounds kind of silly, but really, I want you to learn how to count using a number system other than the decimal number system. And I think we're all really familiar with the decimal system. But two other number systems that we might not be so familiar with is the binary system and the hexadecimal number system. All right, and the reason these are important is bring us into context here. Computers use nothing but the binary system, which is really difficult because us human beings use a decimal system. And in a decimal system, we have 10 numbers. We have 10 digits and no more. And if you want to go back through the history, I think it has something to do with the fact that most human beings have 10 fingers or 10 digits. And that's why we have really a decimal number system. Think of the analogy here with the computer. You recognize the computer has 2 digits. All right, either something's on or it's not on, and that's all it can do. And so somewhere along the line, we have to translate between the two number systems, and that's why we learn to count this way. All right, so let's look at how we count. So we count in a decimal system. Of course, we have our 10 digits, and 0 is 1 digit, and so is 9. All right, so you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and once we get to 9, if you notice, we start recycling these digits. We call it 10, but really it's a 1 and a 0, isn't it? Don't we recycle the 1 because we're all out of digits? And then we go to 11, 1, 1, then 1, 2, then 1, 3, and 1, 4, and 1, 5. Okay, now bear with me. I think you're, 1, 4. Put the right numbers in there. Bear with me here because, I mean, it seems kind of trivial until we start counting as binary numbers. All right? Now binary, again, we only have 2 digits. All right, so I'm gonna put some more. I'm gonna pad this with zeros. Recognize if I put zeros in front of a number, it's still 0. Doesn't matter. 0, 1 is the same as 1. All right, so I'm just going to pad those with some zeros out front. It'll look a little odd, but bear with me on this because I'm teaching you how to count using a binary system. All right, so you start 0. What's next is 1. All right, there's 1. All right, now what? Well, we're all out of digits, so you got to start over again. So our next number is going to be, it goes 0, 1, and then we go 1, 0, and we go 1, 1, right? Okay, now we're out of digits again. So we do what? 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, and then 0, 1, 1, 1. Okay, now we're out of digits again. So we got to start over again. So we get to 8. Okay, it's 1. And then 3 0, 0, 0, 0. We get to 9, it's 1, 0, 0, 1. Follow the pattern here. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. And then 1, 1, 1, 1. Okay? And now we got to add another one. All right. Now my point here with kind of punishing you here with this binary number system is we can see here from this example that we can store numbers 0 through 15, or actually 16 different values, having 4 placeholders, 4 binary placeholders. All right. Now let's look at one other conversion here, and this will be the hexadecimal number. All right, now hexadecimal, hex means 16. All right, so we're gonna have 16 numbers here. So we have, and just think of having 16 fingers. We're gonna need more than 10 symbols because our symbols over here start at 0 and go all the way up to 9, and then we start recycling them. All right, and really what mathematicians will use is we need our symbol. So rather than make up something really wacky, we start using the alphabet. We'll use like a capital A. All right, and it's just, remember, it's another way of counting. So go 0, 1, nothing changes. 2, 3, 4, 5, 6, 7, 8, 9. Now remember, we're not going to start recycling numbers again, so we need another symbol. A, B, C, D, E, and F. Got a capital there for correctness. All right. Now the advantage here. Now if you look at this, we're able to And by the way, notice I have four. This is 4 bits here, right? That's half a byte. Wow. Okay, so half of a byte. So I can actually store a half of a byte or 4 bits in the hexadecimal system using only 1 digit. Okay, versus the decimal system, it doesn't convert nearly as nicely. All right, so these are so this is why you see these 4 different number systems and why they're valuable to folks that are working with computers.